Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, a thin p-type silicon sample is uniformly illuminated with light which generates excess carriers. The recombination rate is directly proportional to the A option is saying the minority carrier mobility, B option is saying the minority carrier recombination lifetime, C option is saying the majority carrier concentration, D option is saying the excess minority carrier concentration. This is true. Now let's see why. If we look at p-type, let's take an example of p-type. In p-type, majority is holes, minority is electrons, and the recombination of electrons in p-type, recombination of electrons in p-type is given by delta n over Tn. Tn is the lifetime of the electrons, and delta n is nothing but minority carriers minus thermal equilibrium value. So we can say NP, that's minority carriers value, actual minority carriers value, minus minority carriers value in thermal equilibrium. So we can say NP naught divided by lifetime of the minority carriers, that is nothing but electrons. Okay, and this is what is this excess minority carriers. So when you subtract actual minority carriers, actually thermal electrons in thermal equilibrium from actual minority carriers, actual electrons, you will get excess minority carriers. So excess minority carriers divided by the lifetime of the minority carriers, that's going to give you recombination of electrons in p-type. So here you can see the recombination rate is directly proportional to excess minority carrier concentration, and that's how we do this kind of problems. I hope this helps. Thanks for watching.